Just in time to kick us off. All right. Well, thanks everybody for joining the webinar today. We're going to hear from Geoff Boehling and Don Whittemore on the Kansas Geological Study's Missouri Region Groundwater Study. Just a little bit of background on this before I kick it over to Geoff. The Missouri Regional Advisory Committee's goals of number 1 and number 2 address the lack of knowledge surrounding the groundwater quantity and quality for the Missouri region. And the Geological Survey, in coordination with the Kansas Water Office, through this study aims to conduct an evaluation on the groundwater in that region, and now analyze the overall quantity and quality, and then develop a digital database with this information. So Geoff and Don will be going through the presentation to learn more about this. And then if you have any questions while Geoff and Don are presenting, please feel free to enter them into the chat, and then we can read those off at the end. So Geoff, I'll hand it over to you now.
Okay, thank you, Amelia. So this is discussing the Missouri Regional Planning Area, so the Missouri River Basin in northeast Kansas, which is on the background map here. So a very odd little shaped area up in the northeast corner of the state. And just as an aside, Missouri Regional Planning Area, MRPA, I pronounce that Mr. Paw. So if I say Mr. Paw, that's what I mean. Okay. So we're talking about the glacial hills of northeast Kansas. And just to kind of put a conclusion first, groundwater production in the area is from isolated patches of permeable material, not what you would really think of as a regionally extensive aquifer. So it's a very different setting from, for example, the High Plains Aquifer out west. The project started in 2016 following an increase in groundwater use around 2010, and I'll be talking about the groundwater use in a little bit. And just as another point of background, I'm the third PI on the project, following Jordi Batia Aguilar and then Andrea Brookfield. So I took it over from Andrea when she left the survey. And the project will end at the end of this coming November. So the overall project objectives are to establish a groundwater level and quality monitoring network in the planning area in Mr. Paw, and provide estimates of safe yield and establish a groundwater quality baseline. And I'll just say at the outset that we basically abandoned that goal of trying to establish safe yield. And I'll explain that as we go. So on the groundwater quantity side, first I'll start out with the map of the well location. So this essentially is our network. So these wells labeled MORAC. Can you see my mouse, by the way?
I cannot see it. No.
Okay. Well, okay, I'm not going to worry about that for the moment. But the wells labeled MORAC are basically former USGS wells, 9 of them that now are monitored by the KGS. I would have named them Mr. Paw, but the names were established before I took over. And you can see MORAC 5-1 there in the middle of Brown County, and then MORAC 28-1 in Donovan County. Those are continuously monitored wells. We have hourly water level measurements there since November 2020. And then USGS 19-3 there up in the kind of northeast Nemaha County is still a USGS well that's also continuously monitored quarter hourly. So the other MORAC wells we've been measuring manually either once or twice per year, and also sampling for water quality. And then we have 2 new deeper monitoring wells. So these other wells are shallow. two new deeper monitoring wells, one up near Reserve right on the Nebraska line, so northern Brown County there. And then the Sabetha well there in northeast Nemaha County. And we have hourly measurements there since September of 23. We also tried to drill a monitoring well just northeast of Hiawatha in an area of fairly heavy pumping, but that well turned out to be all clay, so that's not good for monitoring. And these are the manual water level measurements to date in all those wells. So if you look in the legend at the side, the 5171, those are the same labels as those correspond to the MORAC labels in the map. B1, B2, and B3, those are designations saying those are in Brown County. Then D is for Doniphan and N is for Nemaha. And on the bottom here is a plot of the Palmer Drought Severity Index, the monthly index from 2010 on. And so basically, the more positive that is, the wetter the environment is, and the more negative it is, the drier it is. So, and the first measurements, manual measurements that you see in the plot at the top, and note that the y-axis is increasing downwards since it's depth to water. So the first measurements are by the USGS back in 2010, 2011. And then KGS started taking over the manual measurements in 2018. And so you'll see that there was something of a dry period in 2018. And in a number of the wells, the water levels were a little bit lower than earlier when we first measured them. 2019 was fairly wet. You see an increase. And then after that, water levels kind of dropped back down and have just been sort of rattling around a little bit since then. But overall, you can see that there's essentially no evidence of significant long-term trends. Things are pretty much at the same level as they were at the last USGS measurements back in 2010, 2011. So in three of these wells, that USGS well in Nemaha County, MORAC 5.1 in Brown County, MORAC 28.1 in Doniphan County, we have continuous measurements. And so the top plot shows that. And then the bottom plot shows the drought severity index over this time period. And so again, these are depths to water. And you can see that essentially these wells are responding, so essentially responding to precipitation, which is what the Palmer Drought Severity Index is summarizing mostly. So you can see that basically when it's wetter, the water levels go up. When it's drier, they go down. So these are basically responses to seasonal and annual variations in precipitation. And these wells are not close to each other at all. So the fact that they're kind of moving together essentially just indicates that they're responding to the same signal, which is precipitation together with evapotranspiration, essentially. So the inputs that govern recharge to the aquifer. And then you'll see that you also get USGS 19.3 has the shallowest water levels and responds the most. MORAC 28.1 has deepest, and it's a more muted response, and that makes sense because the impact of recharge becomes more diffuse the deeper you go, essentially. So the interpretation of all that is that those former USGS wells and the one that's still a USGS well, they're all relatively shallow. And these water levels reflect seasonal and annual variations in precipitation, and they show no discernible responses to pumping. So one thing I'll point out is that these water levels are actually going up in the spring and summer and down in the fall and winter, which is the opposite of what you would get in response to irrigation, which would be larger in the summer. And then the current water levels are about the same as those measured by the USGS earlier. So we have struggled to get deeper monitoring wells. And we aimed to get deeper monitoring wells in areas with higher groundwater use. And the highest area of groundwater use is northeast of Hiawatha, where there are a number of wells for the city of Hiawatha and then also irrigators. And we have, early on, we attempted to install deeper monitoring wells using our direct push rig, which is a small rig that you hammer the rods with. And basically, the clays in that area are really sticky and they put up a real fight. And the direct push rig just couldn't handle it. So we contracted with a driller from Omaha to install a well northeast of Hiawatha and then up to the north near Reserve. We got those installed in June of 23, but the Hiawatha well turned out to be all clay, which is not a good situation for monitoring. So that it's all clay despite being in the area of highest groundwater use in the region, excluding the river valley. And then the reserve well is basically all sand. So it's a good monitoring. So while my colleagues were working on installing a reserve well, a landowner from Sabetha drove by and volunteered an unused well on his property. And so we installed monitoring and telemetry equipment there as well. So this Sabetha well is, I'm going to go back to my map here. The Sabetha well is there in the northeast corner of Nemaha County, and so the blue outline is the boundary of the region. So it's kind of right on the boundary of Mr. Paul. So that monitoring well is represented by the blue circle there, and the red circle is the nearest so-called irrigation well. But it's in a city park by the baseball diamond, and it only has averaged 5 acre feet per year for the past 5 years. So it's not a very high use. The monitoring well has a screen depth of 116 to 142 feet. And this is the continuous record from it, which is fairly noisy. So that's the blue line is the continuous measurements. And probably a lot of that fluctuation is barometrically induced. And then the red line is just a smooth curve run through that data. But I want to point out that if you look at the axis, the vertical axis, you're only looking at about 2 feet of variation. So there's not much going on there. And you can see a definite response to the wetter conditions in 2024. And after that, there's kind of not a huge amount of correlation between the precipitation and what's going on in the well. But at the same time, there's just not a whole lot going on in the well. And then the reserve well is the one that's up by the Nebraska line in northern Brown County. So the blue symbol there, pentagon, is the monitoring well. And the circles are irrigation wells that were active between 2021 and 2025. And they had average uses varying between 29 and 67 acre feet per year. The screen depth for the monitoring well is 79 to 99 feet. And that's what its record looks like. So you can see, in the summer of 24 and the summer of 25, you can see clear responses to irrigation. So there's really sharp drawdowns. That's a response to nearby pumps turning on. And then you see recoveries. But overall, so we're definitely not seeing year-to-year declines. We even seem to be seeing kind of an overall increase over this time period. Now, I just wanted to compare this kind of record to the situation that we see when you're actually dewatering an aquifer. So this is from the Thomas County Index well in the Olalla Aquifer south of Colby. And here you see, a strong signal of the spring and summer irrigation. So you get the really sharp declines, and then you get recoveries in the fall and winter after the irrigation season. And most years you see an actual year-to-year decline in water level, and that's because the irrigation is actually dewatering the aquifer. So it's a very different situation. We have no evidence for anything like that in Mr. Paul. So this has an average annual decline rate of about 0.7 feet, excluding 2018, which was a really anomalous year due to a hailstorm, and basically there was no irrigation that year. So I want to talk a bit about water use, and I'm going to focus on groundwater use in the upland area. That's excluding the Missouri River Valley, because the upland area and the Missouri River Valley are very different environments, and this study is focused on the upland area. So the questions are, is there a groundwater quantity problem in Mr. Paul? If so, is it a regional problem or is it a set of local problems? And one of the things I want to point out is that domestic use is not reported to the state, and so it's not reflected in the subsequent slides. So this is the overall groundwater use since 1990, and I've separated out surface water in the Missouri River Valley, groundwater in the Missouri River Valley. From the lower curves are surface water in the uplands and groundwater use in the uplands. And you can see that groundwater use in the uplands is the smallest component, and the upland use overall is much less than what you get in the valley, which makes sense because, of course, groundwater is more abundant. Well, both surface and groundwater are more abundant in the valley. And in the valley, you get both the municipal and industrial use. So again, I want to focus on the groundwater use in the uplands in Mr. Paul. And so that's that curve expanded. And you can see that, from about 2008 to 2012, there was, a notable increase in groundwater use in the uplands. And then it's more or less leveled off. I mean, it fluctuates, but there hasn't been really a systematic increase since then. So the groundwater use for the last 10 years is about 178% of the groundwater use for the first 10 years. And this is the groundwater use by type, averaged over the past 5-year period from 2021 to 2025, represented by the color scale. And note that color scale is logarithmic. So the bottom end of the scale is kind of at the low end of typical household use, and the top end of the scale is comparable to the median irrigation use in Groundwater Management District 4 in Western Kansas. So there's quite a range of use values here. And then this is also broken out by different types. So municipal and irrigation are really fairly comparable throughout the area. And then you get a smattering of other uses. So the background on this map is essentially the footage of coarse sediments above bedrock, so between bedrock and the land surface. And so the coarse sediments are the ones that are really permeable, that you can actually, pump a reasonable amount of water from. And I'm showing that together with the groundwater use using the same color scale as the previous slide. And essentially what this slide tells you is that the groundwater, the really significant groundwater use tends to be, isolated to regions of, thick, good footages of coarse sediment. And those regions tend to be fairly isolated. So again, we're talking about sort of patchy, permeable areas that are not connected in a regional fashion. So the overall conclusions on the groundwater quantity side are that the water levels in the shallow monitoring wells have been roughly stable since 2010 or 2011 and show no discernible impacts of pumping. In terms of the two deeper wells that we have, there's essentially nothing significant happening in the Sabetha well. The reserve well shows clear response to occasional pumping, but no evidence yet of any kind of long-term decline. But we need a few years of record before we can really say anything definitive about it. So in terms of groundwater use, the upland groundwater use ramped up around 2010 and then roughly stabilized. Significant pumping is from a few isolated areas of permeable material, not a regionally extensive aquifer. So to my mind, it doesn't make sense to talk about safe yield on a regional basis. So any problems that exist in terms of quantity are local, involving a limited number of stakeholders. So the fundamental problem there is that the groundwater resources of the region are limited by the geology. So there's not really a problem that can be managed at, in terms of human intervention at the regional scale. But that being said, there are significant groundwater quality issues that need to be monitored. And for that discussion, I will turn it over to Don.
So I'm Don Whittemore, and as Geoff said, I'll talk about the quality part. So we go back to the well locations again. We've got the Nemaha County, and then to the east, Brown County, and then to the east of that, Donovan County. That's where we have the upland water wells. And again, Geoff indicated that those are shallow ones, except for the Sabetha and the reserve. And the advantage of having those shallow wells in terms of water quality is that we can see water quality variations in a time frame, say, of this particular study. The water quality in the deep water wells do not change as much, so you need more decadal kind of observations and be able to really tell some of the major changes going on. But we do have both of those. And I might mention that although the survey was not able to get in a good well in Hiawatha, I did get water samples from the public water supply wells of Hiawatha, so we could look at the water quality there. They have had problems with nitrate being over the drinking water standard and have had to go spend a lot of money for treatment. And so I did some examination of what is the source of that. First of all, let's look at chloride. Now, chloride does not get high enough in these particular wells to be of concern. The recommended drinking water level is 250 milligrams per liter. And you can see that the graph doesn't even go up quite that high for chloride in the y-axis. But we do see some wells have great changes. 2 wells here have great changes in the chloride concentration, whereas the other wells in general have low concentrations, generally all of them less than 20, except for one of them in Nemaha County gets a little bit above 20 and has been rising a little bit with time. But we see these 2 particular wells have quite different sources of chloride. Now, the one in green with the X is in Brown County, and that is a bedrock formation source. So when it is a dry period, because this is close to a stream, then there's not much recharge, of course, from precipitation, and the stream will drop. And when the stream drops, you begin to get more discharge, more flow of groundwater towards the stream, and that will also then flow past the shallow monitoring well. And that discharge not only is within the shallow aquifer, but also some of that then comes up from the bedrock. And I'm able to determine the source of this based on the geochemistry, utilizing bromide to chloride ratio versus chloride concentration. I'm not going to show that, but I do have that slide in case there are any questions that come up on that method at the after our presentation. So then when it rains, when it's very wet, there's a lot of recharge to the groundwater. And so it dilutes that. And you see, we go from the highest chloride down to a very low chloride. So we're going for something over 200 all the way down to 12. And again, that's because of all the rainfall coming in, recharging, and then having more the flow in the groundwater and also flow in the stream. Then we'll have the fluctuations in the weather, climate, and it will go up and down, as you can see. The one with the plus symbol, is a well in Donovan County, and that is a road salt source. It has a different geochemical signature. And so that will not necessarily just follow those wet and dry periods. It's more seasonal based, of course, on when the road salt is applied. And then if there happened to be a particular event that could wash that road salt into the shallow groundwater. So we see that that will fluctuate a fair amount also. Now, the concern in terms of water quality is the nitrate. So the y-axis is nitrate nitrogen. Nitrate is NO3, 1 nitrogen atom and 3 oxygen atoms. But typically the standard is reported as the amount of nitrogen in the nitrate. And that standard is 10 milligrams per liter. The MCL, the maximum contaminant level. And so you can see that a lot of the wells in this area exceed that particular drinking water standard. Both of the deep wells, Reserve and Sabetha, you can see over on the right-hand side, the green stars and the kind of a wagon wheel symbol for Sabetha are above the 10. And then we see we've got wells in the different counties exceeding the 10, but we also have wells that are fairly low in nitrate. Now, interestingly enough, we have this well in Nemaha County that started out when the USGS first put in the well. It was very high. We can see it was above 45. In other words, like 4.5 times the drinking water level, drinking water standard. And it has been decreasing with time. Now, I looked at aerial photos of the area and found that it's been since 1991 when I looked at the first aerial photo we have for this particular area that's online that you can also look at, that through time, the photos show consistently an agricultural area. You can see the contours of the land. You can see the farming in that particular area. So it's very interesting that the nitrate was able to decrease with time. So it must be that they were able to manage that with less fertilizer to the system. And so we had that slowly being diluted with time. Other wells, we can see we have some fluctuations, again, probably due to some of the climatic conditions up and down of rainfall recharge, dilution, or maybe the opposite thing of helping to flush some of the fertilizer nitrogen down into the subsurface. So we have both shallow wells and deep wells that exceed the nitrate standard. And again, that can become very expensive for public water supplies such as Hiawatha that would be required to treat that, because the MCL means, if it's exceeded, means that you cannot serve that water out to a public supply. I mean, individual domestic people can drink it if they want, but for the public water supply, it cannot be served. So how do I know this is mainly fertilizer source of nitrate? Now, this slide looks pretty complicated, so I'm going to lead you through it step by step. So in the y-axis, we have nitrate, nitrogen again. And for the x-axis, we have chloride concentration. Now, both of these are logarithmic axes. So, for example, for the nitrate nitrogen, you can see where it has 1, 10, and 100, the distance of the y-axis between 1 and 10 are the same as between 10 and 100. The same idea on the chloride. And what this allows me to do is to spread out the values, because if I use the axes that are not logarithmic, you see a whole bunch of these points all clustered together. It would be difficult to see how they separate and be able to say something about the interpretation. The next point on the slide is to see the dashed line at 3 milligrams per liter nitrate nitrogen. That's the usual maximum natural nitrate concentration. Then for 10 milligrams per liter, you see kind of the orange-red dashed line. Again, that's the MCL, the maximum contaminant level that public water supplies are able to serve to the customers. Now, the next I'll point to are the purple P's. And P stands for Palmer. The Department of Health and Environment did a study in the area of the city of Palmer, 2 counties west of Nemaha County in Washington County. And this is an area where there's a lot of animal waste. And the best fit line through the wells in that Palmer area are showing the increase in the nitrate nitrogen with chloride. And if you continue to extend that line up off of the graph, in other words, to higher nitrate and higher chloride, you go up to the actual composition of both dairy, cow waste, and then also the hog swine waste. So this is the kind of best fit line you get for that kind of source. In other words, the higher the nitrate, the higher the chloride. The next thing I will point to is the H symbol, kind of in the middle, and that stands for the Hiawatha supply wells. Again, those are the public supply wells. You can see those are over the 10 milligrams per liter. That's the raw water from the wells, not the well water that is being treated and served to the customers in the city. I had these well waters analyzed for the nitrogen isotopes and the oxygen isotopes in nitrate. And there is a method for being able to use that information to tell whether it's a fertilizer, inorganic fertilizer source, or a manure type source. And this came out showing that it is an inorganic fertilizer type source. So now we'll start to look at some of the other wells. We can see down in the lower right-hand part of the graph, we've got this 11.3, where the chloride is affected by the bedrock discharge. We have low nitrate. And then we have the ones that are the plus symbols affected by the road salt. So in this particular case, I can't really tell whether this is the nitrate that would go above the MCL would be the fertilizer or manure, because the road salt chloride obscures that relationship. You know, certainly somewhere in the uplands, there's probably some very local places. If there are some stockyards, you know, feed lots, where there might be some groundwater from the animal waste source. But in general, this upland area, it's mainly fertilizer source. So let's look at some of the other points that are above the 10 milligram per liter level. We can see the red diamonds. We can see that is a completely different trend in the nitrate and the chloride than we see for the animal waste source. And the other ones as well, we see that they're more horizontal or just a very slight change in the slope And these do not at all fit the animal waste source signature at all. A couple of the other ones, we see the one in Donovan County, the blue circles, and then the kind of deep blue squares in Nemaha County. Again, those kind of a vertical change in the nitrate without the chloride changing much at all. Again, that does not fit the pattern that the animal waste source shows. So again, we have mainly the fertilizer source of nitrogen, of nitrate, contaminating the groundwater in these upland areas. So the conclusions here for water quality, we have high nitrate levels indicating mainly inorganic fertilizer sources. And we have some variations, but they probably would reflect application rates and the precipitation recharge. Now, monitoring wells, we find in riparian areas, those treed areas of drainages or waterways that might be in fields tend to have lower nitrate concentration. So if we think about wellhead protection in the area, things such as unfertilized grassland and grass strips, or if we had extensive treed areas around the wells, those could help keep the nitrate concentrations lower. Wells screened above the bedrock, I've shown you, can have impacts from mineralized water from the bedrock, and these will have higher dissolved solids concentrations during droughts. We don't have that water to dilute that and keep that bedrock salinity from coming up. And then an issue for the long term might be a slow increase in chloride concentration over extended time due to road salt being applied. And so that would affect areas near the paved road. So right now, we don't see anything high enough to be of concern, but the concern would be with time, is this going to increase such as it does, for example, in more northern parts of the United States, where it does become of quite concern. And then I'll turn it back to Geoff.
Okay, so as I said, the project wraps up at the end of this coming November. We'll have one more monitoring sampling round this coming fall. Another thing that's happening is I'm working on reassessing the sediment distribution over a somewhat larger area encompassing the northern part of Mr. Paw, based on the driller's logs. And I'm doing that partly to get kind of a better visualization, because the shape of the region makes visualization a little awkward. And then as this project wraps up, my intention is to hand responsibility for these wells off to the survey's Aquifer Water Quality for Kansas program. So, and there's a link to the project website down at the bottom. So, any questions?
Thank you for the presentation. I don't see any questions currently in the chat. If anyone has questions, now would be a great time to enter those in there. But I guess a question just from me, as far as the data that was collected, that will all be incorporated into what would be available through the Aqua program, and accessible by the public that way.
Yes, that's my assumption. Yeah. That's my intention, let's say.